Assalamualaikum warahmatullahi wabarakatuh. My name is Genta Sentosa with ID student 123490009. I'm from Instrumentation and Automation Engineering student from Technology Institute of Sumatera. So in this video, I will present you about the application of counter PLC on pneumatic system. So we will start to present it. This is our last practical pneumatic. So the goal of this practical is to understand how the counter PLC, how the counter in PLC works, how to use CNT and CNTR instruction, and how to connect them to the output in a pneumatic control system. So let's start discussing by the basic concept of the counter. So the goals of this practicum is to understand the principle of the counter in PLC and CNT, CNR, and how to connect them, just like how I said. So a counter in a PLC is a function used to count the number of pulses or signals that occur in a process. For example, in a pneumatic system, every time a sensor is triggered, such as a proximity sensor detecting the piston movement, the PLC receives a pulse input. The counter function keeps track of how many times that signal occurs. Once the number of counts reach a specific value, which we call the preset value or PV, the counter output will turn on. In simple terms, the counter is like a digital version of a mechanical counter. It increases or decreases the count based on the signal it receives. Now let's talk about two common types of counters used in PLC. The first one you can see on the screen is counter up or CNT. The counter up counts every time the input signal goes from off to on. For example, if a button is pressed or a sensor detects an object, the counter will increase by 1. In on-prem PLC, that format looks like this: CNT 000 and then hashtag 10. The 000 is the address of the counter, and the hashtag 10 it means that the preset value is 10. When the counter's current value reaches or exceeds 10, the counter output bit, for example C0000, will turn on. And then the second type is CNTR or counter reversible bidirectional. So this type of counter can both increase and decrease depending on the input condition. One input is used to count up and another input is used to count down. For example, a sensor detecting forward movement adds on, while another sensor detecting backward movement subtract 1. The CNTR instruction is written as CNTR 0001 hashtag 10. This means the counter will activate its output when the current count reaches 10, and it will deactivate again if the count drops below 10. So why uh, why we need reset? Like in many industrial process, we don't just count once. We need to restart the counting process after a certain condition. That's why we use the CNR instruction, which stands for counter reset. When CNR is triggered, it resets the current value of the counter back to 0. This is very useful when we want to repeat a process, such as a pneumatic cylinder, moving back and forth in a repetitive cycle. So let's talk about the ladder diagram. Uh, we can see we will learn how we apply this in a ladder diagram. In our practical using the Omron PLC trainer board, we can design a ladder circuit like this. Yeah. Then I will show you how to uh, make this ladder PLC. We will open the CX programmer or Omron maybe, and then we will just follow the circuit based on the module. So we'll follow the instruction. Okay. Mm. We will make the diagram, and we will add switch first. We will add switch, and then we will name it PB on, and for the value is 0.00. 0.00 PB on for the command. Okay, and then we will make the switch for off. Okay, 0.01 PB off, and after that for the output we will add the output. uh, we will name it system. Okay, and then we will add okay, that's for the first layer, and then we will continue to the next layer. We will continue to the next layer. Switch CNT. Okay, the value is 0.02, and the command is switch is CNT. Switch CNT. Okay, then we will just follow the diagram of this module. Wait. Uh, contact with. Yes, and then continue to the next. We will add ladder diagram. Ladder, this is ladder. The instruction is counter up 000. Okay, okay, that's all. Hashtag 10. The comment is uh, counter up. Okay, counter up. Okay, then connect the component. Then I will add timer reset. Okay, we will add timer reset. Timer reset. Sorry, not timer reset, but T000. T0000. Timer reset. Timer reset. Okay, then we will connect to this side. Yes, like this. Then we will add C000 for the counter up. C000 counter up. Okay, then we will make a ladder diagram again right here. Then team 000 hashtag 50. Okay, team 000 hashtag 50. For the comment is timer reset CNT. Okay, okay. And then we will continue. Okay, W0.00 system. Okay, this timer reset CNT. Nah, okay, and then we will continue to the next step. We will make CNTR reversible. The previous one we have made the CNT, the counter up, And now for the next step, we will make the CNTR or counter reversible. Okay, we will just click the new layer and then switch CNTR system. Okay. 0.030 switch CNTR. Okay, then system 0.0 system, then sensor slice PB1, sensor slice PB1. Sensor slice PB1. Oh, sorry, we got the wrong address. Should be W0.03 sensor slash PB1. Okay. Now system. 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 Okay. We'll continue. Then add the ladder again. CNTR 02. Okay. The instruction is CNTR 012, CNTR 012, 012, and then 001 hashtag 10, 0001 hashtag 10. Okay. The comment is CNTR. CNTR. Okay. Then next W02 W0.02. The comment is sensor PB2. Sensor PB2. Okay. Then next, connect to the ladder. Okay, we will next for the timer reset. Timer reset T0001 T0001 timer reset. Timer reset CNTR. Okay. T0001 timer reset CNTR. Okay. Then we will connect to the beside it. After that, C001 CNTR. C0001 CNTR. Okay. It connect to W 0.05. W 0.05. For the comment is CNTR. CNTR. Okay, we will connect, and then we will make the ladder again. Okay. Add the PLC instruction, and then we will instruct to team 001 hashtag 50. Team 0001 hashtag 50. Timer reset CNTR. Yes. Okay. Okay. We have finished the last layer. We will continue for the last layer. Okay. W.0000 for the system. Use 0.00 system, and then W 0.05 for CNTR and CNT, and 0.06 0.06 CNT 005 for the CNT. Okay, the next key is 100.07. Key 100.07. Okay. CNT 006, CNTR 05. Oh, this it use the new close contact, not the other one. Okay, CNT. Oh, it just reversible. So this is the W 0.06 for the CNT, and then here is the W 0.05 for the CNTR. Okay. Oh, this is wrong. This is W 0.06 CNT. Okay, and then here is W 0.05 for CNTR. Then add here. Is that right? W 0. CNT CNTR. Key of why it wait, Control X 300.07. Okay, why is it red? CNT. I think there is a mistake, but I don't know where is the mistake. Mm. Okay, I will check where is the mistake. The CNT should be wait. I think I missed something. Oh, oh yeah. This is this should be uh W 0.06. Maybe I will delete this. Uh, W 0.06, and for the comment is CNT. Yes. Nah. Okay. Like let me. Okay. Is there is something that I miss again? Counter up. T000. Wait. T000. I will check the layer one by one. 0.02. Maybe that's all that I could tell you about the presentation. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.